What's up, everybody? This is Mr. C. Happy Monday morning to you. And I have a great STEM experiment to kick off the week. Today, we're going to learn about the planets. That's right, the planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and I know it's not a planet, but I'm going to include Pluto right in there.
Thank you.
For what?
For wanting me.
Hey, those are our planets. And today we're going to learn about how far away they really are compared to what you see in the books. Right? Now, let's talk about our materials before I get into this. First thing, if you can get your hands on some accounting paper, right? This nice long little thing of accounting paper. Great, you're gonna need about that much. Wingtip, your wingspan, fingertip to fingertip, wingtip to wingtip, right? Now, you don't have to use this stuff, right? If you can just tape together 8.5 by 11 pieces of paper, you'd probably need about 5 or 6. If you are insistent, but you don't want to go to Smart and Final or Office Depot and buy a pack of 100, let me know. I'm here Mondays and Tuesdays. I can totally tear off a couple sheets for you so you guys can do this at home. Okay? You're gonna need a pencil. I've got a pen here just so you can see what I'm doing. You're gonna need a pencil or a pen, and then of course, markers. I'm gonna use markers just so you can really see how bold the colors are, but hey, if you're a crayon student, if you're a color pencil student, if you're one of those, the smelly marker where they smell like strawberry student, whatever you want to use, okay? All right, now that we have that out of the way, let's talk about why we're doing this. How many of you have ever seen a picture of our solar system, of all the planets? Go ahead and raise your hand. Okay, yeah, I have too. Now, when you look, did the picture in the book look something like this? Come on. It's okay. Come on, you can show them. Okay, oh good. Okay, there it is, right? You've probably seen a picture that looks something like this, right? Look at all the planets. They're all nice and in a line, and you know, Mercury, Venus, Earth, Mars, Jupiter, Saturn, and they're all perfectly in line, and they're all in the same distance. Unfortunately, that's not how the planets work, right? And I'm going to show you that today. Actually, the planets are a lot further away than we think of, right? How many of you have ever thought, like, I don't understand, why can't we just go explore the planets? Like, just, you know, get in a spaceship or a starship and just go.
Help Warp 1, engage!
Well, hey, hold on. We're not gonna do Warp 1 yet. Not gonna do any warp speed around here, okay? But we're gonna talk about how far that really is, okay? All right, so if you're ready to join me, hey, get your materials, get your paper, get your pencil, get everything, and let's get cracking. All right, folks, so I've spread out, and this is about how long my arms are. It actually goes a little bit longer, but I figured this was a good way to show you, and this is gonna be our solar system, right? Now, obviously, the solar system is huge, but on one side, what I want you to do, get your left side, right? Then you have your right side. So what we're gonna do is we're gonna take on our left side, right over here, right here, we're gonna draw the sun, okay? Now, I don't care how you draw the sun. The sun is a yellow star, so I'm gonna go ahead, and you can do this in marker, right? So we're gonna draw the sun, and there it is. And then go ahead and color it in, right? This isn't just, you know, science, and don't worry about art and everything. I want you to take your time, do the best job you can, right? I'm gonna draw a little rays, just like that. Right? And there is my sun, okay? And let's go ahead and take a look, zoom in, and there it is. There is my sun. Okay, now what you can do, we're gonna go ahead and label this. Like anything, wanna make sure we have a good label here. Let's go ahead and label, I'm gonna label on top, sun. Just like that, okay? All right, now on the other side, we're gonna go ahead and, this really depends on what you want to do here, Okay, so I'm going to take all the way over to the right side of our solar system. Okay, you have a choice here. If you are an old school Pluto kind of guy or gal, right? You love Pluto. Pluto should still be a planet. Pluto forever. You can go ahead and put Pluto here, right? Just draw a circle and Pluto. You can also put in, if you are kind of like, no, Pluto's not a planet, Pluto's a planetoid, and you know, really it's the Kuiper Belt, you can put that as well. So I'm going to go ahead, let's put this right here, and you can see exactly what I'm going to do. I'm going to go ahead and write here, and I'm going to go ahead and write in, just for new school, I'm going to draw the Kuiper Belt. Mr. C, what is the Kuiper Belt? I've never heard of that before. Well, it's really the collection of planetoids, asteroids, mostly made of ice and rock. It's the edges of our solar system, right? And we're going to go ahead, and the way you spell it, K-U-I-P-E-R, Kuiper Belt, Kuiper Belt. Perfect. So on one side, you should have the Kuiper Belt at the furthest ends, right? And then on the other side, you should have the sun. Okay, now what I want you to do is we are going to take our solar system, and I want you to draw where you think the planets are. All right, now this is just, you can do it based off the picture that I showed you. You can really do whatever you want here, but I want you in pencil or really light pen, go ahead and draw where you think the planets are, okay? So if you want to follow along with me, I don't want you to copy me, but you can follow along with me and see where I'm going to draw them. But if you are like, Mr. C, I already know where they are, I totally got this, cool, right? If you haven't and you have no idea about the planets or where they are, then go ahead and follow along with me. So I'm going to keep my solar system there, and here we go. So we have the sun right here, and let's go ahead, tilt it down a little bit. Perfect, look at that. There's the sun. Okay, now let's draw our first planet, right? Mercury. So you can see I'm going to draw this, and I think Mercury's, I know it's very close to the sun, right? And I'm just going to do a circle. You don't have to draw this to scale. And I'm going to go ahead and write Mercury. Now Mercury, it's actually very fast. It goes around the sun very, very quickly. How quickly, Mr. C? That's a good question. Actually, circles does one revolution of the sun in 88 days. It's very fast, right? That's why they named Mercury after the Roman messenger god. He has wings on his feet, really, really fast. All right, let's go ahead and next one, Mercury is Venus. And I know Venus is pretty, it's pretty far from the sun, but it's still nice and close. It's a little bigger, right? But I'm just putting it, and I'm not really drawing this to scale. Venus, V-E-N-U-S, Venus, named after the Roman goddess of love, Venus. All right, now we have Mercury, we have Venus. Don't forget, we have Earth, right? Earth is getting kind of far away, but there's our planet right there, Earth. And let's go ahead and do that. There we go. So we have Mercury, Venus, Earth. And now what's next? Mars. That's right. So I'm doing this in black pen or pencil just to show you these are where I think they are. And then the second part of the experiment, I'm going to show you where they actually are. Okay? What's after Mars? Well, we have Jupiter. Now I know Jupiter is really far away. So I'm going to keep my sun right here. And let's go ahead and move over. Yeah, so now Mars is out of the picture. Mars is right there. You can kind of see it. All right. So then here's Mars, and then let's go Jupiter, I think is going to be right here. I'm going to write it kind of big. Oh, Jupiter. I misspelled Jupiter. 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 There you go, Jupiter. All right. Not bad, right? Looks like we're doing well. We have Mercury, Venus, Earth, Mars, and now we have Jupiter, right? Pretty big. Now let's keep going, right? Because I know I've got another planet, and that's the famous ringed planet of Saturn. That's right. So let's go. And I know Saturn's kind of far away. We're going to put it over here. I think Saturn is pretty far away. So let's go ahead and put Saturn. And I'll draw some rings just so we know it's Saturn. Perfect. And then let's go ahead and label it Saturn. All right. Next one is Neptune. Oh, sorry, not Neptune. Uranus. I'm thinking of the the Roman god of the sea, but really I need to get to Uranus. So we have Jupiter, Saturn, Uranus. It's a very odd planet. It actually is, Uranus is right here, and it's a very, very big planet, but what's cool is it's lying like on its side, right? Which is really cool. Now, a couple things about the planet, Uranus, Uranus. All right, let's go back as we're doing this. Mercury, Venus, Earth, and Mars, right? These are all planets, right? They all are solid planets. They're made of rock. I mean, you can go and land on Mercury. You can land on Venus. We obviously live on Earth. And we've actually landed things on Mars rovers. Jupiter is a gas giant. It's very, very big. You can't land on Jupiter because it's full of gas. Same thing with Saturn. Can't land on Saturn. It's a gas giant. These planets are huge. Now, Uranus is also a gas giant, but we also call them ice giants because these are very, very cold planets. These are like freezing cold. They're so cold it actually freezes methane and some of basically gases they survive on Earth as a gas. It's so cold they're actually liquid and they can freeze on Uranus. Next we need Neptune. Now what's cool, Neptune is the Roman god of the sea. If you're a Greek god kind of guy or gal, this would actually be Poseidon, but Neptune. Very cold and very far away. Also an ice giant. And last but not least, we have our Kuiper Belt, or Pluto, if you please. Okay, let's take one more look at our solar system. And this is how I have them spaced out. This is how I think, I know they're really far away, okay? Mercury, Venus, Earth, Mars, these are our inner planets. And then we have Jupiter. Next we have Saturn. Next we have Uranus, very cold. Next we have Neptune. And next we have the Kuiper Belt, or Pluto, if you'd like. Okay. Now hopefully everybody has... There we are. Hopefully everyone has written down their solar system. Okay, so I want you to take a minute. If you haven't done it, finish up. Once you're finished, go ahead and grab your markers because we're going to draw where the real planets are, right? That's right. I'm going to show you a trick to show you how far away the planets really are. Stay with me, finish your guesses, and then I'll meet you back with your markers. See you then. Okay, folks, here we go. And first thing I want you to do is we are going to take our huge solar system and we are going to fold it in half. All right, so take your sun and go ahead and match it up with the Kuiper Belt, right? It should look something like this. Okay? You're going to fold it in half and make a nice crease right here, okay? And it should be the exact center of our solar system. Now we're going to go ahead and unfold it. Now, does everybody see where that is? That nice center right there? Guess what that is? That is Uranus. I know, right? That is Uranus. So go ahead, and I'm going to go ahead and put my camera here. And this is where you are going to draw Uranus. Okay, so go ahead, and Uranus is a kind of a sea green. It's a really cool looking planet, kind of a medium blue, greenish. So, and it's big, so I'm going to go ahead and draw a big planet here, and I'm going to color in some of that. Oh, look at that, perfect. Okay, I'm going to add a little bit of green, just a little bit. Oh yeah, that looks good. Here we go. Okay, and then now let's go ahead, and it does have a faint ring around it, so I'm going to draw, and it actually is on its side like that. Its axis is tilted. Pretty cool, right? All right, so let's go ahead and label this Uranus. U-R-A-N-U-S. Uranus. Cool. Next thing we're going to do, let's go ahead and we're going to fold the sun like this. Everyone see the sun? Go ahead and take your sun and meet it up with Uranus, just like that. Go ahead and fold it down, just like that. Nice fold right there. Perfect. All right. And then now what we're going to do, undo that fold. You should have a nice fold right there. And guess what planet goes here? That's right. Saturn goes here. Wow, that's pretty crazy, right? Yeah, these are actually planets are very far away. So Saturn, it's kind of a brownish yellow, right? Now again, you can look at some pictures, color it in how you want. Brownish, yellowish, orange. It's actually very pretty, I think. And of course, you don't want to forget the rings. There we go. There's our brown planet. And then I'm going to draw some other, that's Saturn. Okay, now once you've finished that, add some yellow in there. Perfect. Oh, there we go. That looks great. Okay. Now don't forget to add your rings. Just like that. Boom, boom, and then add another ring. Perfect. And there is Saturn. Let's go ahead and label Saturn. Perfect. All right, what's next? Next thing you're going to do is, remember how we folded the sun into Uranus? Well, we're going to do the same thing, but now we're going to fold our Kuiper Belt into Uranus. So go ahead and do that now. Boom. Kuiper Belt into Uranus. Open it up. And now, you know what you have here? Yes, that is actually Neptune. Yeah, I was actually pretty close. Not too bad, Mr. C. I may have done this once or twice. Now, Neptune's, it's a kind of a blue, light blue to dark blue planet, right? And it's big. So I'm going to draw it like that. And then I'm going to get a darker blue and really just kind of color it in, right? Yeah, that's what Neptune looks like to me. An ice giant, very cold. Not bad. Neptune. Cool. So what I'm going to do now is all of these places where I've folded, I'm going to go ahead and write my measurements, right? So we folded Uranus, and this was the halfway mark, right? We folded the paper in half. So you should have something like that. All right? We folded from the sun to Uranus, so half of a half would be Saturn, and that is a quarter. So a quarter of the distance, Sun to Saturn. Okay? And then we folded Uranus into the Kuiper Belt. So this is going to be Neptune is our 3/4 mark. Not bad, right? So we're doing some fractions here. Kind of cool. All right. Now we've done most of our gas giants. We're still missing one, and we are missing Jupiter. I wonder where Jupiter is. All right, this is getting fun, right? Go ahead and take Saturn. You have your Sun. Go ahead and fold the Sun into Saturn. There we go. Fold it in. And now we have 1/4, right? So if I have a fourth here, 1/4 is going to be 1/8. And that is going to be Jupiter. Now Jupiter is another giant planet. Don't forget the big red storm. It's huge. Now I'm going to draw it kind of like this. I'm going to put that, and just, again, I'm not trying to win an art contest here, but just, you can get kind of creative with your, oh, there we go, put some yellow. You got some yellows and browns and oranges. And then, again, don't forget that nice big red spot right there. All right, I'm going to put, there's my giant red storm. Oh, I actually tore a hole in the paper. I was coloring so hard. Pretty cool. That's Jupiter. All right. Wow, man, I was kind of off there. So my guess was really far away here. But it's right here. All right, what's next? Keep folding. All right, Jupiter. We're going to fold the Sun into Jupiter. So let's go ahead and do that. Sun into Jupiter. Pretty cool, right? Here we go. And bam, right here on the Earth. Well, what goes here? You know what goes here? We have something that we didn't put on our original thing. This is called the Asteroid Belt. Yeah, there are a bunch of asteroids in between the inner planets and the outer planets, Jupiter, right? So I'm going to go ahead and put some dots here. All right, so, and again, we folded 1/8, right? 1/8 would be 1/16. Wow. And this is the Asteroid Belt. Cool. Just like that. Not bad, right? Asteroid Belt, Jupiter. Well, now what do? Well, now we fold the Sun into the Asteroid Belt. All right, let's go ahead and fold the Sun into the Asteroid Belt. Now that we have that, let's go ahead and mark it. And 1/16 is 1/32. And you know what goes right there? Mars. Mars goes right there. That's right. Our red planet, Mars. Just like that. All right, Mr. C, what about the rest of the planets? Mercury, Venus, and Earth. I'm glad you asked. Guess what? Mercury, Venus, and Earth all fit right there. These are the inner planets, so close to each other. These are the outer planets. Look how much space there is. All right, go ahead and finish up your drawing, and I'll meet you for our outro coming up now. All right, everybody, let's finish up our lesson here. Now, I've gone and put our solar system up here, and you can see how far away, I mean, when I really stretch it out, you know, we go over here, and we have the Sun, and then all of a sudden now we've got Mercury, Venus, Earth, Mars, all right here. Oh, look out. And then the next stop is Jupiter, right? That's a long distance. And then the next longest distance, Saturn. Then we go all the way over here to Uranus, all the way over here to Neptune, and then all the way here over to the Kuiper Belt or to Pluto. Now, I want you to remember, okay, the way our planets orbit, and I'm going to get into these measurements here, but the planets, they don't orbit in a circle. And that's what it looks like when we look at our textbooks or the picture I showed you at the beginning, right? It shows, you know, here is the sun, and here's the Earth, and it goes around in this perfect circle forever and ever and ever. It's not really how it works. Earth's orbit and the other planets' orbits are actually in an ellipse. And let me show you what an ellipse is. Like an oval, right? And it kind of goes like that. Again, that's not really to scale, but that's how your planets orbit the sun. And for a lot of different reasons, gravity, other planets and their effect on the planet Earth and their relationship with the sun. But as you see, right, it's difficult to really illustrate this in a textbook, how far away the planets really are, okay? It just is. So it's one of the main misconceptions a lot of people have is, I don't understand, why can't we just fly, get in a spaceship and fly over to Neptune and let's check it out, man. That sounds great. That's a very, very long distance. Okay, let me put this in perspective. Today, it is August 24th, 2020. We have, to this date, only have 2 man-made or human-made objects that have left the solar system. And I'm talking, I don't mean like to the Kuiper Belt, I'm like, it's gone and it's now in interstellar space. It's left our system and it's on its way to another star. 2, they were launched in the 70s, Voyager 1 and Voyager 2. Now I'm gonna throw up some pictures here. Voyager 1 over here, Voyager 2 up there, okay? It's really cool, but it's taken over 40 years. I mean, and it's going very fast, right? In our the way we look at fast, right? Launched from Earth, it's taken 40 years just to exit the solar system, okay? So you can see these distances are vast, right? It takes you from Sebastopol to Santa Rosa, it's about 7.4 miles. How long does it take you to get there? 10 minutes, 15 with some traffic on Highway 12, right? How long does it take to get you to San Francisco? You know, 45 minutes, an hour and a half, depending on traffic. It's only really about 40 miles away. Now imagine traveling. This is where we're gonna get into the measurements. I've got Earth to Mercury, right? So Earth to Mercury, that little distance right there, right? Little tiny distance. 57 million miles. Million miles. And that's one of the shortest distances. Earth to Venus, which is kind of cool because Venus is considered our twin, even though it's very, can't really live there. A relatively short 25, let's just round it up to 26 million miles. What does that look like? I'm gonna round it 26 million miles. 26 million. I'm gonna say it again. Million. Okay? That's a lot. Let's do Earth to Mars. Earth to Mars, again, about 49 million miles. Hey, that's not too bad, right? That's actually pretty close. Now, let's get into some of the outer planets. Earth to Jupiter. Only this far, really, right? Again, on the map, it doesn't look that far. Yeah, 390 million miles. See what that looks like. 390. That is, ladies and gentlemen, 1, 2, 3, 4, 5, 6 zeros. 390 with 6 zeros. Okay? Takes a long time. If we were to travel there, it would probably, the shortest it would take us, maybe about 2.5 years. And that's like if everything is lined up perfectly. Let's go to the outer one, Neptune, right? Earth all the way over to Neptune. 2.7 billion with a B, billion, right? Billion miles. That is 2, comma, and then how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, basically 9 zeros. That is an incredible distance, right? Even if we were traveling the speed of light, which is how fast light travels. Light travels incredibly fast. How fast does it travel, Mr. C? It's something around 186,000 miles per second. So it's very fast, okay? To put it in context, sun to the earth, right? The light, it takes light from the sun, the big ball of gas. Light exits the sun and reaches earth. It takes about 9 minutes, right? It takes not, so the light you're seeing right now outside, that light's actually 9 minutes old. If we were to the speed of light from the sun all the way over to the Kuiper Belt, you're looking at about 4.5 hours, right? We can't even travel that fast yet. And it's still going to take you 4.5 hours to get to the end of the solar system. So these are incredible distances, okay? So this whole lesson is just to teach you space is vast, okay? And this is just our solar system. We're not even talking about the rest of the galaxy. We're not even talking about the other galaxies that are billions and trillions of miles away. So right now, let's just focus on our solar system. But you can see, that's pretty awesome. Hey, I really hope you guys enjoyed this. As you can tell, I really love space. I love science. If you didn't know, I love Star Trek. So it's always nice to put this in perspective again to see how far away things really are compared to what we see in the books. Hey, if you enjoyed this, great. Make sure you subscribe to me, okay? Subscribe, click that little bell, click subscribe. I do want to leave you with one thing, right? This is something you can do at home. If you want to see a really great rendition of this, I need you to click over here because there is a video by Mark Rober, and he actually does this on I think it's like a football field, and he shows you again, along the same distances, right? But he actually does it to scale. Like he shows you, the scale of Mars, and he does like a little P. It's actually really cool. Hey, check it out. So again, click up there for Mark Rober. Don't forget to subscribe. This is Mr. C. See you all next time.